Yeah, roots of unity. And what was the roots of unity, Alyssa?
The a number to the power of n would have n roots.
Yeah, that's right. And so like we looked at particular examples. For example, z cubed is equal to 1. That's what we call a root of unity, right? Because it's like, what are the cube roots of 1? And so we realized, as you mentioned, that actually whatever n is over here, whatever the power is, it should actually have that many solutions. But we only looked at that for 1. And so I guess the question is, can we apply this to any complex number now, not just, 1 or negative 1, something like that? Could we do this for 8i? And the simple answer is yes, we can. Do we need to change much is sort of the question, right? Well, I want to show you two approaches. I want to show you a kind of sort of a visual, like an intuitive approach, and then I'll show you the algebraic way, because I think that's probably the more general approach you want to take. Let's just think about this though, right? 8i, what does that actually look like on our Argand diagram, right? 8i lives kind of over here. So, like this, right? And a key part to solving this equation, at least for one solution, is actually just to think about this as, okay, what does z cubed equal to 8i mean? This means that I have some value such that I have z multiplied by z multiplied by z, and that's going to equal to 8i, right? But then, do you remember, like when you are multiplying a complex number by itself, right? What are the rules, particularly with the modulus and the arguments? You guys remember, maybe take two complex numbers first. If you multiply just two complex numbers together, what did we do with the arguments? Do you remember? You add them, and the moduli, you multiply them. That's right, yeah, if you multiply them, right? So naturally, if we multiplying it 3 times together, right? Well, the modulus, we're cubing it, right? And the argument, we're multiplying it by 3, right? So if we're just wanting to do the reverse of that, well, the same idea, we can actually, what would we do? If we want to reverse it, we'd take like the cube root of this modulus. Or if we wanted to find the argument of what z would be, we could just divide the argument by 3, right? So what is the argument of this guy? So the argument of 8i, well, because it's just 90 degrees there, we can see that. Modulus of 8i? 8, yeah, right. It's not meant to be a trick question, it's just saying, hey, what's the distance from here to the origin? It's 8. So actually, you can actually find one of the solutions for z really easily. You don't have to do any algebraic approaches here. You can just say that z is equal to, well, the cube root of this would be 2. And the argument, well, we'd have to divide this by 3, which would be pi on 6. That's actually one of the solutions there, okay? What does that look like? Well, it looks something like this. Pi on 6 is 30, hey? So actually it should be a lot smaller than 8, the modulus. So something like this maybe, right? Would you guys agree? That looks kind of okay, right? And so you can actually use this sort of visual approach to find the other solutions, because remember, what other thing did we realize? Well, not only are there n solutions to these equations, but they're all equally spaced about the Argand diagram. So you can actually use this method and find the other solutions as well. But I'm going to formalize this a bit more. I'm going to actually give you like some steps you can follow and some sort of rules that are going to allow us to find all the possible values of z for this, okay?